was able to make a periodic table. Who was that chemist? Mendeleev. He wondered if nature really had a master plan, if the elements had a pattern that one could understand. So he bought a bunch of cards, and on each one wrote the name of an element and its weight, and then he played the game. He put them all in order by their atomic weight.
Welcome, Honors Chemistry students, to our Chapter 5 test hints on the periodic table chapter. If you have printed your test hints, or if you're watching these early, you know that we have 45 questions on this test, and it would really help if you had your list of test hints handy with you while you're watching these videos so you can follow along and, of course, figure out what questions you need to ask when you get to class. So starting off with number 1, what characteristics Mendeleev used to arrange his periodic table? And this is early on in the notes in your chapter. Remember, Mendeleev only had about 63 elements to work with. He did not have all the elements that we have today. And his table was like ours, but turned 90 degrees. So Mendeleev's table looked more like that than the one we use today. Remember that for a test hint later on. The big thing he worked with was properties. Properties of the elements were really important. Get us set back on the right track there. Eventually, things were kind of in order by atomic mass. He wasn't sure about the atomic number at that time. Properties were the key, because that's what he used to predict other elements. Which takes us to test hint number 2, what the spaces in Mendeleev's periodic table were for. Dmitri was a smart guy. He knew that there must be some other elements that existed out there. I don't think he had any idea how many more we would find or create, but he knew that there must be more based on the properties of the elements that ended up around them. So he left spaces for elements like scandium, gallium, and germanium. If you go back and listen to the song I had playing at the beginning, you'll hear all about that. Test hint number 3. Who arranged the periodic table by atomic number and why? That was Moseley. Henry Gwyn Jeffreys Moseley. Not sure if I spelled that right. I'm taping these kind of late on a Friday afternoon, so bear with me. Henry is the one that put the metal samples in the cars of the toy train, sent that through the X-ray machine, zapped it with X-rays, looked at the wavelength bouncing back, and figured out that things were changing consistently, and used that process to identify the atomic number. When we put the elements in order from atomic number 1 all the way up to now 118 or close to it, all of the other things kind of fall into place. We don't have to worry about the glitches that we have with mass. When you go from lowest number to highest atomic number, you can make the length of the rows on the table such that the elements with the same properties fall in families or columns. Number 4, the test hint says why the periodic table is so useful to chemistry. Hello, it's got everything on it. Some of you in the last chapter made note of the sage advice that you got from Mrs. Levin. You said, everything's on the periodic table. Look at the periodic table, it's all there. The periodic table lets scientists predict new elements, what their properties are. It lets us predict how things are going to react, what they might react with or not react with. Very useful in that regard. So it's a predictive piece as well as an informational piece. Test hint number 6. What elements added a new row to Mendeleev's periodic table? You might remember in the notes that I have stars next to this, and I said, make sure you pay attention. Remember, Mendeleev's table was turned compared to what we have now. And where we have columns, he had rows. And also keep in mind that when scientists were trying to figure out what elements were, what ones existed, were there any new ones out there, things we hadn't discovered yet, they were doing a lot of wet chemistry. They were seeing what could react to make something new. They were seeing what could break down into simpler substances. And with the technology of the time, which was not very advanced and certainly not electronic, these noble gases that don't react with anything, they really had no way way to identify those. So when we did finally identify the noble gases through their spectra and some other methods, then they added a new row to Mendeleev's table, but it's a new column on our table. Please, when you read these questions, stop, think, is this question asking me about a row on the table, which is also called a period or a series, or is the question asking me about a column on the table, which is also called a group or a family? Unfortunately, sometimes I see people kind of just twist that backwards and they know the concept, but then miss the question because of a very simple mistake like that. So take your time, read the questions. And that brings us to test hint number 7, the specific names of the F block elements. And we have 3 different names for those. Certainly we can refer to them as the F block elements down here in the bottom 2 rows. They are also called the lanthanide and actinide series. Lanthanide because they start with the element lanthanum. Sometimes you see that written as lanthanoid, really doesn't matter. And the actinide series. Lanthanide and actinide because they start with lanthanum and actinium. They're also called the rare earth elements, rare, even though some of them are more abundant than some of the D block elements, and the inner transition elements. I don't know if you can really see this on camera, but my little bookmark here has a periodic table in the expanded form. You saw this in one of our inquiry activities, where the F block is moved up in between the S and P block, kind of where it should be. And we talked about the fact that having the periodic table spread out that long might not be too convenient, it's a little cumbersome. But they would go within this area, kind of between the S and D block, so they're called the inner transition. D block is the transition elements. Alrighty, moving on to test hint number 8. How the periodic law relates to the periodic table. How does periodic law relate to periodic table? Well, you definitely need to know what the periodic law says. Chemical and physical properties of elements are periodic functions of their atomic number. And again, it goes back to our rearrangement of the table in order of atomic number and the idea that we're going to make the rows just long enough so that elements with similar properties are going to fall underneath each other. Okay? So it relates to the table because it helped us shape it, the way it is. It helped us make sense of the elements and organize them based on their properties. Test hint number 9, state the periodic law. Well, rewind a little bit, and I just told you that. Certainly that is something you can look up if you didn't catch it a couple seconds ago. Test hint number 10, how elements in a group on the table are related. Okay? Elements in a group or column on the table are expected to have similar what? By the way, that was the test question. I'm kind of reading it here from the test. I'll throw some of those.